so-called task sequences or workflows in a way where those tools are really neatly decoupled from each other. And ideally, you would then be able to, if you want to execute a different task with a different tool, then you should be able to easily switch that one tool out without all the others affecting each other. Then, yeah, let's talk a little bit about the core use cases that Keptn comes with. So the first is basically automating observability, dashboards, and alerting. What does that mean? So basically, you can integrate your monitoring solutions by writing so-called SLI providers. So those are services which need to adhere to a certain interface that Keptn specifies. And if you choose to write such a service or reuse one of the existing ones, you can use that one to integrate it into Keptn and then maybe automate the setup of your monitoring and the retrieval of certain SLIs, or service level indicator values, that you might be interested in during the deployment or the evaluation of a new version of your app. All right, and yeah, basically on a very high concept, the way this works is if you choose to onboard a new project into Keptn, you feed it this kind of shipyard.yaml. So what's that? Shipyard basically describes which stages you have within your project. So for example, the development stage, staging stage, and production stage. And within those stages, you can define different workflows. So for example, you can define a delivery workflow. Let's see if that's exactly. Yeah, so this example is not completely up to date with the spec, but on a rough level, you can describe different workflows, like a delivery workflow, where you say, okay, first I want to deploy a new version, then I want to do a evaluation, for example, check if all the criteria are met, for example, the response time of your service. Then if that passes, the next step could be, for example, a release into that environment to really switch to the new deployed version. And if everything has passed in that particular stage, you can also link certain stages together. So this means that the successful delivery of a new artifact in the development stage, for example, would then trigger the delivery sequence within the hardening stage, for example. And yeah, if you want to evaluate your metrics, you can give it a so-called SLO, so service level objectives.yaml, where you basically describe your criteria that you want to fulfill with your service. So you can, for example, say, okay, I want to evaluate the P95 percentile for my response time, and I want all or most of the requests to have a response time of smaller than a certain value. So this is kind of this declarative way how you describe your goals that your service is expected to achieve. And yeah, this picture basically recaps what I've just said. So as you can see here, you can link together those kinds of stages, and between each of the stages you have this this gatekeeper, so to speak, which ensures that only if in the previous stage everything has gone right, the delivery in the next stage will be triggered. All right, and yeah, this is kind of the bigger picture of this use case. So for example, you again have the shipyard YAML and the SLO YAML, and then together with that you can also use the continuous delivery functionalities of Keptn to describe your Helm chart that you want to deploy. So this will then be stored in internal Git repository More on that later when we have a closer look at the architecture. And then Keptn will take care of deploying this Helm chart on your cluster, executing the tests, and then evaluating the SLIs. And yeah, from a use case perspective, I think I would like to leave it at that because I really want to focus more on the architecture. So I think, are there any questions so far, by the way? All right, then let's dive into the architecture part. All right. So this is the high-level architecture of Keptn. And yeah, maybe what's worth mentioning here is the way the system is implemented is it's event-based. So basically we have this central orchestration component in Keptn, which is part of the so-called control plane. And the name of this orchestration component is the infamous shipyard controller. So it's kind of the engine room of Keptn. And this one basically is responsible for orchestrating these sequences. So we will see that in detail in a few slides. So basically for a sequence, it will send out so-called task.triggered events, which will indicate that a certain task is expected to be executed. And then the execution plane services, which live here, are subscribed to those events. And based on the information of the Keptn's uniform, so the uniform describes which service should fulfill which task. So for example, the deployment task should be executed by the Helm service, and then the Helm service will listen for the deployment or triggered event, fulfill that task, and then when it's done, it will inform Keptn by sending back an event again that this task has been executed, and then it can proceed with the further execution of the sequence. At the left, you see a Git repository. So we are following the so-called GitOps approach in Keptn. So GitOps means that pretty much all the configuration for your application, like the Helm charts, for example, or in addition to that, the SLO YAML, where you specify the goals you want to achieve, are stored in a Git repository. So that means that every change to the configuration of your application can be traced back by looking at the commit history, and then Keptn can also use that, for example, to automatically roll back to a previous version by just checking out a previous Git commit ID and say the Helm service, for example, okay, this version we tried out now was crap. Please, dear Helm service, switch back to this old version of the Helm chart. All right, and yeah, the interface to this Git repository is the so-called configuration service. Yeah, basically all the Keptn execution plane services who might need a certain configuration, like the Helm service with the Helm chart, or the evaluation service, which should inspect the SLO values, can use that configuration service to fetch the configuration for that particular service in that particular stage of the project. Then we have the data store. This one basically subscribes to all the events that are happening within Keptn and stores them in a MongoDB collection in order for you to afterwards be able to inspect the event trace of a certain sequence and see basically what Keptn did. Then finally we have the API service. It's a very generic name, so I guess this has kind of a historical reason. So back then when we started out with Keptn as a prototype, pretty much the complete API was only living in the API service. now it's all the functionality basically has moved to the shipyard controller. So this is, yeah, especially in this microservice kind of environment, seems to be a common thing for the architecture and the API to be kind of a moving target, especially during the early phases of development. But of course, eventually, this should become more stable. The API service is nowadays mainly responsible for accepting events that should be sent into Keptn. And then you might have noticed those little Ds that are at several places. So this is the so-called distributor. And the distributor is our implementation of a so-called sidecar pattern. And this one is responsible for subscribing to the events that the respective service is interested in by first registering itself at Keptn at the so-called uniform API, where it will get the information which events it should be interested to and it should be subscribed to. And then it will either, if it's running in the same cluster, it will either directly connect to NUTS, so that's our message broker. And when it has received an event, it will forward this to the actual service by calling the localhost HTTP call, where the service is listening for event payloads. Or if it's running outside of the cluster, obviously we cannot connect to NUTS directly. In this case, we have API for retrieving events or actually tasks that should be executed for a certain sequence. And why did we do this distributor sidecar pattern? Originally, we started out with, actually it has two reasons. Let me just quickly go to the slide where that's kind of documented. So originally we based Keptn on Knative eventing. So that seems to be seemed to be a good fit for Keptn because of the serverless kind of architectural approach that they were performing, even though you needed, I don't know, at least 10 virtual CPUs and 15 gigabytes of RAM. So that's maybe a hard sell for serverless. And also then also the eventing component of Knative basically allowed you to easily subscribe to events by defining the correlating custom resources for Knative. And in theory, this looked nice. And in the beginning for the prototype, it was working well. But eventually we were more busy debugging Knative instead of developing Keptn actually. And then we kind of very quickly had to switch to a different technology for the eventing part. And our services, which were previously Knative services, now are running as normal Kubernetes deployments and services. And since we just didn't have the time to implement the event subscription in all the services, because that's the other reason we started out with all the services being written in TypeScript, and then we migrated to Golang. We just didn't have the time to re-implement this in several different libraries for the services to subscribe directly. So that's why we went with this distributor sidecar approach, where we have this container running the distributor inside the same pod as the service itself. And so with that, we achieved this language agnosticness, where the service itself only has to provide an HTTP interface where the distributor can send the received events to. That worked out pretty well actually for a long period of time, but there's always a pod. And that's why I chose this example, because I think this is a nice anecdote of how quickly this architecture can morph from one thing to another. Eventually, we wanted to go further towards being production ready. And one aspect of that is to be able to do zero downtime updates. So basically, during an upgrade of Keptn, we now have the requirement of the API being reachable at all points of time, and also the execution plane services to be able to complete fulfilling tasks by retrieving and sending back events to Keptn. And there, because of this distributor sidecar pattern, where we have two containers within the same pod, we kind of had some challenges during the termination of the pod that was running with the previous version, because, for example, if the actual service is still processing an event, but the distributor is already down, the service cannot send the distributor to forward events back to Keptn anymore. And that led to sequences being stuck because the finished events were not being sent back, and vice versa. The other problem was that, for example, if a new pod has been started and the distributor is already connected to the Keptn control plane and receiving events, in that case, the service itself might not be ready yet, and that also led to lost events. And that's the point where we finally said, okay, now we need to implement the functionality of subscribing to nodes directly in the services, because obviously this makes the synchronization between the two containers much easier. But nowadays I think we don't have any TypeScript service lying around anymore, so we're completely in Go now. So now we can use our library that's currently being written to directly subscribe to events. So I think this was a nice example of how we could make use of this language agnostic approach that the sidecar pattern provided us with during the phase where we transitioned from one technology stack to the other. And now that we have completed this migration from TypeScript to Golang, actually we did it a long time ago, but still now we have that, and now we have the possibility of switching to this simpler approach of directly subscribing. Yeah, I think I skipped that, but very quickly, the way how those event flows are working for a sequence, so we know what I was actually talking about just now. So during a sequence, the shipyard controller, so the orchestration plane, when it receives a sequence.triggered event, it will first of all fetch the correlating shipyard YAML for the particular project that you want to trigger the sequence in. Then it will see, okay, what's the first task of the sequence, in that case the deployment task. Then it will send the deployment.triggered event to the execution plane by sending it to nuts, and then eventually it will reach the subscribed execution plane service. Then this one will respond back with a started event to indicate that it has started the execution of the task, and eventually when it's finished, it will send the finished event, and then the shipyard controller can continue with the next sequence. And then, as I said before, there we had the problem that if, for example, the finished event was not sent back, then the sequence was stuck, and we had to put on our detective hat to see what's going on in the environment where that happened. But yeah, hopefully this will get easier now with our zero downtime support. And yeah, I think yeah, at half an hour. So I hope this was of some interest to you. And if there are any questions, I'm happy to take them now.
How do you deal with the fact now that you have still outside services? Because if I get the architecture right, you have now partly internally or partly outside. Because there you still have those staged events, right?
Exactly. Let me just jump back to the overview slide. So for now, the requirement of 0 downtimes is only for Keptn Core, so that's not completely solved. But, and that's another architectural challenge we have right now, as I said before, in the distributor, we provide either subscribing to NUTS if we're in the same cluster, or with via the API. And obviously, this is not 100% ideal because we need to support two more or less completely different ways of subscribing. But at least in that case, if we're going to the API, this is working a little bit differently. So this one pretty much holds all the events, the triggered events that are currently open, so to speak. So for unfinished tasks that are still to be executed. So in that case, if the execution plane service is down due to an upgrade or to a crash probably, then eventually it will, in this case, it will not miss the event because it will still be available in the respective collection, and then it can just afterwards call the API again, and then it will still get the information that this event needs to be handled. All right.
Was there any particular reason why you switched from TypeScript to Go? Is it just the way to do cloud native development?
Basically, it was in the cloud native world, it is the way to go, so to speak. Yeah. So most of the CNCF projects and Kubernetes itself is written in Go. And for that reason, also if we eventually decide, and I'm looking to Giovanni to write operators, then we can use our experience here with that technology.
So are we taking that path now?
Pardon?
Are we taking that path now?
I would be up for it, but obviously that's for the product owners and product managers to decide. But operators are fun, so. All right, yeah. Then if there are no further questions, thank you for letting me talk here. And yeah, if you're interested in the project and have any follow-up questions, maybe you can always contact us on Slack, Twitter, etc. All the social channels that are out there.
Also check out the documentation, which is pretty good, and see, not only how you can integrate it maybe to your challenges that you're facing, but also again contributing to that community, because it's really fun to play around with that thing, set it up with K3S or whatever you want to use, and get going with Keptn in like 2 minutes, maybe 5. There's a video on this on YouTube.
All right then. Thank you.
And thank you from my side as well.
Thank you.
Wonderful talk. And maybe in addition to, if there's any further questions, I think you will stick around for a beer, right?
Probably, yeah.
So if there's any further questions, you can ask him directly also over a beer right away.
Of course.
I would suggest that we take like 5 minutes break, and then we will continue with the second talk by Christian Zellot. So see you back in 5 minutes.
So, the stage is yours.
I don't know why Java is so good like that, but everyone thinks to do it. Like those new things are really strong. But it was only certain parts. I think you had to have the right GK and you had to define it as an alpha and as a java. If you get that certain combination, you should have mentioned that was right. Do you compile with variable VM or? I actually love that, but it's still struggling with getting all the plugins done. But I made it run over the actually small. Overseeing stuff and then usually it's like the hardware at the moment is still cheap enough to just figure stuff out instead of saying a little bit. I'm sure that you will do this stuff. It's just
whereas site container, maybe 1 gig of RAM versus 2 Yes. Okay, that's nice.
Afternoon is always a good idea.
It's basically package loading has to be based on Spring Boot.
Like instead of really old written PHP. The oldest PHP version is still quite some stuff is okay.
What are you using? I guess then there's message bus, so what are you using there?
Depending on the size and on the message flow that you use, whether you do only like small fast messages, you could put some nice. Also, the routing is being more elaborated. But all the use cases are just like we call them the main line, so you just put them on the bus and say, whoever will consume it, take it. Kafka is back and forth because then you don't have to deal with storage or Kafka will just keep that stuff where you really do it.
Kafka is a central component, basically also for future development and so on.
We had US and it was always when you are not sure that consumers are doing the job good, then you have a switch for revenue and Kafka is I'm keeping up. And scales are really
there's been pretty large effort in really evaluating what we need. Also, when it comes to really, having a robust implementation and not needing to clear code too much, being able to scale, really, digesting all of those efforts, faster. And in the end,
we use the Kotlin stats.
Just in terms of scale, what's the heavy lifting you need to do in your platform?
We have there's two things. The most I would say data intensive one is national data. So stations depending on so we have charging stations basically. And the stations are sending depending on what the customer set up, the manufacturer set up, and the speeds of the 30 seconds to 5 minutes before this. Each interval consists of like 1 to 20 minutes. That have different sizes.
But I guess when it comes to judging infrastructure and operating them, basically serving with what about real-time requirements?
Yes, we have as well. But anyway, we can decorate. And also we have most of the white label apps, and those white label apps also connect the status declaration is quite a big
Consider that like we're building services on top of that. That means that working on specific use cases need to consider, at least to some extent, all Kafka, how messaging works. So there, yes, there is a lot of enablement going on for teams to really work with that system, able to, meet those non-functional requirements earlier.
Okay. Well, welcome back to the second talk. It's my pleasure to announce Christian Zellot, who I studied with and haven't had too much to do work-wise in a while. So I'm really interested in seeing what he will present. Something about Spring Boot and Kotlin so far, but I have no clue what we will see there. But I'm happy to listen to you.
Thanks.
At the stage.
Thanks for having me. As Veit already said, my name is Christian Zellot. I'm working at Has2Be, which is a not so small company anymore in somewhere in the middle of the Alps in Radstadt. So you probably know Obertauern or Schladming or so. And we do everything around charging stations, basically. So that's our business. That comes from operating them, having stuff for e-drivers, having stuff for the companies operating the charging stations. Like everything is around there. We have now got bought by ChargePoint, which is an American company, but at least at the moment we are still called Has2Be, and our big logo is still there in the office when you come to us. And what I do there is basically we call it dev leads, but basically we have like Scrum teams, and I'm, let's say, have the architecture role and the senior role because I'm for the company side quite long there, it's 5 years, and I've seen all the, let's say, nasty stuff and fun stuff which we have and Has2Be. So out of that, I'm a senior there. And we mostly do, at least in my team, Java and Kotlin for newer services together with Spring Boot. I'm also quite often using Flask with Python as a web framework, and also we have PHP still left there, which is our big old monolith. From time to time we have still that as well. So you see, I'm doing quite a lot of languages. So what I want to go through basically is like, why the hell Spring Boot? Isn't that like an old Spring already? Why not plain Java? What I personally like and dislike so far is really opinionated, to be honest. Like some special topic, which is common pitfalls with the JPA. So like your database layer, because I at least made some nice experience with that one. And yeah, for what I've used it so far, I'm going to like give you a short ideas. And what I have is like a private project with Spring Boot, which I'm going to show off some code, how it looks like in real, together with Kotlin. So. Yeah, why Spring Boot still, right? as I put down the alternatives, there are like plenty of other ones which are a little bit more cloud native and probably maybe a little bit faster in boot up time. The thing is just like what I experience now with my colleagues is just like they get easily in because everyone has seen Spring Boot. It looks everywhere the same. I think nearly every Spring Boot application has its similar patterns. So the developer experience is quite nice. And you have a library basic for everything. So I haven't found something in the last couple of 2 or 3 years where we're using it heavily, where I couldn't find something and say, okay, it's nice integrated, just use that one. Yeah, and out of that, it might be a little bit old, it might be a little bit boring, it might also be the most performance thing, but on the other side, when you can just put it on a Kubernetes cluster, it works anyway, and you just scale it up, and it's fine with the resources too. Other alternatives which I've looked so far at is Quarkus, which looks quite promising. It's a little bit more on the cloud native side, also a little bit more with the gray VM, probably a nice look. Micronaut as well. Helena I just found out because I did a bit of research, looks also interesting, but haven't tried it out yet. But looks really similar, like Quarkus, Micronaut, Helena, also Spring Boot at the end. Like the structure looks quite similar. Ktor would be the native Kotlin way. It's like the framework that the Kotlin guys bring up. But from my point of view, it looks really minimalistic. It's probably rather the Flask versus Django. If you're familiar with Python, then Ktor looks like more the Flask word. Yeah, and probably the other libraries and frameworks as well, which I haven't touched in. So why Kotlin and why still Java? Because I also use it quite often. Kotlin has really less verbosity. So when you write code, it's really nice. You have like condensed classes, you have condensed lines of code basically. So how you structure code looks way less bloated than actually you have in Java. So what I now will do and try to find the right stuff is basically I just put out some examples. So what I mean with verbosity is like Kotlin, for example, has data classes, which is really awesome. Like, I don't know how often you write DTOs. I do that quite often. And those things you just write and write. You have a lot of getters and setters and those things. You write it to string methods, equals. You always want to ensure that you have like final properties maybe or not. You like all those things, right? And it just works in Kotlin with a few lines. Basically, like that same line is probably a huge block of code just in Java. And they come up with later with the, just go through the list. Those data classes and those verbosity goes even further because when you have a look at that, that's somehow data fit in. Usually we get it via JSON or something like that, but probably you have like those data classes somehow filled. And what they immediately come with is they already have like a toString method, which is quite nice. So let's just run it through once. They have equals methods, which works quite good because they do property-wise comparison, which is a thing usually you implement somehow. They have some, let's say, optimized comparison operators. Like the equal stuff is, you don't have to type the equal stuff anymore, right? It just works as you usually would do, and every other programmer just does in other languages. You have things like a hash code implemented. Yeah, so all those things that you anyway going to implement, you just have them there, which I personally really like. And what you also have is you have, for example, with data classes decomposition, which I quite often use because I get out one property of some class. So like all those things which you often write in Java with a lot of lines and looks quite big, you just have it in Kotlin. Then one thing I just really love about Kotlin is the null pointer thing, because Kotlin just comes with null safety. I don't know how often I usually write null checks in Java otherwise. And you just cannot get them, or really hard get them. Of course, you can still get them. You can just write the exclamation mark and still fall in a null pointer. But I mean, it's really your fault then. The mutability stuff is something which I really like. The var and while stuff, like it's just put in a language. I use it quite often, and it also kind of helps the developers, from my point of view, also the juniors, to write the code a little bit easier. And they really just make it naturally, from my point of view, and they always just go for the constant way when you tell them that once. Instead of when you do it in Java, it's a little bit more hassle, right? You have to write more words, you forget about those things. And what I also like, probably a little bit opinionated again, because I wrote so much Python in the last years and so much PHP, is like you can use functions again. Sometimes it makes sense, you know, like those static classes are nice, but you have like huge static utility classes somewhere. They do a lot of stuff, probably they can mix stuff, and in Kotlin you just write those functions. So I like that, at least probably it's my Python word that I now somehow got. But makes really sense. One thing though, is not all libraries feel really native yet. So I stumbled here and there about some stuff, because you can use all the Java libraries that you want, which you can spin up just a Maven project and you have the stuff there. But still sometimes, because they are not like native Kotlin, some methods feel weird, some callings feel weird. But from a gut feeling, get better over time, because especially when you work with Spring Boot, they have like a nice integration. They also care about the Kotlin world in a way. So yeah, that's basically why I really like it. I think I have more or less the same slide again. So as I said, the DTOs, you write quite often, right? That's the thing where you have data classes now. You can just write them. Pure functions, I said. What did I miss? What also comes quite nicely is the tooling around I really like. I know in Java there's also code styling thing, and you can use also that one. But it somehow feels nicer because probably it's a younger language, and they just have stuff like Keptn. We just have an auto formatter, you know. I don't care about how the other developers, the formats and stuff is just built in the pipeline, it will fail anyway. So this is easy to set up, basically. It's just like one command line. Each project looks the same. There's not even much things that come there. What I really like, what really looks weird at the beginning, and really looked weird to me, is that you can put those function names in those sticks. It's like, why do I want to use that, right? I can have normal white spaces and function names. I used it quite heavily for tests. Because when you write to test stuff and you say you verify that and that, you don't have those awkward underscores somewhere and stuff like that. So you just can write nice speaking names. I think some of you who might work with the JavaScript world, I think that's more common, right, in those chests or however the libraries. So I liked it. Some things which are really weird, what I still have and which I kind of probably will not get used to fast, is like, there are some weird like if-else statements sometimes when you want to assign stuff. So that block of code where you decide that just one number is bigger than the other one, the A and the B and down will assign it backwards. For me, it just looks weird. So I have that quite often because IntelliJ will always say, hey, let's format it that way. And then I do the auto suggestion thing with IntelliJ. It comes up with that and it's like, okay, I'm going to revert it back because it just looks strange. The second thing is the companion object. As Kotlin has those static methods anymore, you usually write those on those companion objects where you could somehow have static methods. You have that there, but at least I would go for functions then when you have them. Also, what is a little bit different to write is that whole constructor overloading, because usually in Java you can just have those 5 constructors, right, where you put different variables in. It's somehow a little bit feels not so native anymore. So out of the thing that they I think really focused on this whole class to get really condensed, when you go to things like those constructor overloading, or also it's a little bit more like everything basically it's around overloading sometimes feels weird. On the other side, what you then can do, let's see if I have that here, which I think I missed on the previous slide is, although the overloading looks somehow strange at the beginning, what I really like also is name parameters. So when you go like the way, say the first name, I'll probably do it right. You can just like assign the parameter you need. I do it quite often also in the code because it helps you on restructuring a lot, right? When you refactor certain parameters and positions and things like that, it's nice to just name it that one because it doesn't matter which position you have to construct or whatever method or parameter. It's a thing I really enjoy with Python as well, because yeah, it just makes your life easier on those refactoring things. You're gonna refactor some methods anyway, and you're gonna restructure method names and positions and things like that. They also have some other fun stuff. I just came up with, let's say, more or less virtual example. But basically, let's assume we have like, in our case, for example, you have charging stations and you would receive errors and you usually map those errors maybe to an enum where you do stuff. Then you maybe want to format it in a way that the user can read it. So what you as well have is like functional interfaces. So you can just like define an interface for a function because everything in Kotlin is a function. And then just say, okay, you know what, the second parameter is function. And then override the function on the time that you want. And in this case, you would, for example, have an enum and a nice function which formats stuff for the user. So everything around Kotlin is really functional. That's what I wanted to show. Probably it's not the nicest piece of Kotlin there, but the idea is there that the they build a lot of things in there which we didn't have in Java yet, where you can just spit out a lot of crazy stuff, which you have a hard time in Java. So where do we use it? Typically use it. So our typical stack is, and our typical tasks that we have is like we have some streaming data, either it's via Kafka or RabbitMQ. So there Spring Boot comes just nicely in because it has a nice integration. You just hook in, read the stuff, it even gets the object perfectly formatted in. You can just consume that. Then the typical CRUD operations, right? We have just APIs where we do stuff, calculate stuff, but potentially we have the according REST APIs, and there again Spring Boot shines because you have automatic Swagger documentation and all this stuff. So that's the nice thing that you get out of these big frameworks. Yeah, and also what I really like now with Spring Boot, it really nicely integrates also with the whole Kubernetes world, out of the way how they do monitoring and those endpoints and all those things that they have there built in. It's just nice to get it in. So we use it quite heavily in Kubernetes for that. And you can just use the tooling there, and it feels like everything is nicely integrated. One pitfall though, which we kind of, at least I found in some stuff, is due to the fact that those data classes are immutable and are usually finer, you're going to have some troubles with the JPA when you don't think about like what you're doing. Because usually you have those entity classes, right? Let's go for one. And it's like a private project that I'm currently working on. So you have, for example, those data classes, right? Which would be just an entity. Let's take like a new stuff where you have text before and after. And what you have to do is, when you use data classes, you have to override the equal. Why? Because the equal internally in the JPA will check all the properties. So when you have like a one-to-many connection, it will go and fetch all the stuff, right? So you should override that one in this case because it's not so smart to have the data class. So otherwise you're going to have a nice Dynatrace insights time when you see a lot of SQL stuff going on. That's the thing with the equals, which you should use. By the way, there's like, I think it's JPA Buddy, the plugin is called, that will just warn you when you do that stuff. So that's quite good. The hash code is more or less a similar thing, because internally it will use some properties and load some stuff. So you should avoid that. Just override it with the default Java way, then it's fine. And the same then goes basically for this toString, because again, the toString will load the stuff. It will just make a nice representation, for example, of a list. And if you have a database object or somewhere, it will maybe make a query just because we printed out something. So something you really should avoid. Why then still use the data classes? Because it still comes with the things with the decomposition, for example. So the data classes just fits nicely in there. Yeah, so also one thing that somehow is then, as you have those normal constructors in JPA, where you usually want to have an empty constructor, because the JPA will then insert those things with the getters and setters. You have to make a no-R constructor, or there's even a Maven plugin or a Gradle plugin which just like implements it during the compilation phase. So that's fine. But you should take care about that. But that's immediately fine, right? Because the JPA will complain. Then the other stuff, as I just mentioned, is because Kotlin classes are fine by default, you should make them open, because otherwise the JPA and Hibernate will not be able to proxy them, which will work still, but bring you some performance downsides because caching and things like that is not working as expected. And on the first side, data classes are not fitting nicely because you have to override those three methods that the data classes would bring. But on the other side, like decomposition, and copy, I forgot, come out of the box, which is again nice. So at least you can use still those features, but you should override those. And if you have like IntelliJ, it's just like two keystrokes. Yeah, so I didn't. How long did I speak now? I think probably was fast. Yeah. Yeah. So what I would do now is I just brought a doing home work stuff project because my wife has a small shoe shop, and what I basically built is like a backend for an app, because I built also an app where you just like see news and yeah, have some like customer cards and stuff. So that code I can show off without getting some trouble somewhere. And how does the Kotlin code basically look like? So as I said, like JPA entities look really the same as they do in Java. The exception is that you can just go with those constructors with the data classes. You just have to override those things. Then you're fine. Repositories again look more or less like the same than they would do in Java. What you already see here, what probably might look weird to some Java developers, I have now like both classes in the same file. because for those things, it just feels naturally that I always have those simple repositories in the JPA classes. So at least for those projects, we usually combine them together because you easily find them, and the whole way how you load classes just feels somehow nice. Then you have like, I would say the typical Spring Boot applications, right? You have some service packages where you do some stuff. Let's go there, for example. Spring Boot, Kotlin comes with a lot of like list functionalities as well. That are some are also in Java, but a little bit nicer to read. It's like those, you see those weird calibrations there, which you usually do with a filter and all those things. It's just like a little bit, from my point of view, a little bit more easier to read. But the rest looks more or less again like Java code. Exception like here again, I have function, which is just a static function, somewhere hidden down, which just does some stuff. So just have it here for a function, for example. Or let's go for REST controller. How does that look like in Spring Boot? It's more or less the same as in Java again. The only difference is again here not the constructor, right? It's just like the block here. You have the block there with the function and get mapping, but again, it looks more or less like the same as you have in Java. So for the experience that I made for each Java developer, it's really easy to come up with that. So I have some folks in my team which just worked with Java beforehand. It took them 2 or 3 days to just get used to that. Let's see if I find something funny. I have that one. Like how does the starting thing look like? It looks a little bit different than your typical Java application because that's the main entry point. In this case, it's just a function and the Java class, which starts or marks Spring Boot, and that's it. Yeah, I think I'm more or less through.
Okay.
Yeah, was fast, right? Yeah.
That's fine. So questions.
I have that one. I am, by the way, Veit told me I'm allowed to say that. So if you want to go to the mountain somewhere, we are looking for folks. And if you want to look me up, it's my Twitter tag, and you can also find me on LinkedIn. And I think if I will put the slide somewhere, I also have put some links there for resources to look at. The Kotlin page is really nice. They have nice examples there. They even have a playground, which you can type in stuff there and see how stuff behaves. Yeah. Now, questions.
I have a question. If I want to convince my employer to use it, what would your top 3 arguments be from an employer view or from a company view to invest the effort of switching to Kotlin instead of Java?
I would came up at least with 2 things immediately. Like the first one, which annoys me the most, is the null pointer thingy, which just comes. And the second one is the immutability, because that also is somehow so deeply built in that it's just like nice to use. And you make less mistakes with that from my experience. Just like had yesterday a merge request where a colleague just changed the var to a val, and then it's that one character, but you immediately see like, why are you changing that, right? Like make that sense. Or when it's somehow like in all those characters mixed, it's for me like harder to read those things. It's just more bloated, so you can less focus on the actual business logic and have to focus a little bit more on the language and those topics around. So that would be my primary argument. Also more or less was the argument that I came up with that him. And what also was at least a big argument for us is that we still can use the full Java toolchain. So we can just use everything there that we want. We can use each library. It's really not a big effort. It's the Maven setup just looks the same as in a normal Spring Boot application. It just has, I think, 2 or 3 more plugins in there. That's it. The rest looks like, it feels like Java in a way, but the writing and those things are a little bit easier from my point.
What would speak against switching to Kotlin?
I don't know. As I've used it now quite some time, especially with the combination with Spring Boot, I wouldn't switch back. I mean, I would not switch now all the languages I have in Java just for the purpose of switching, because probably, although you can do it, I guess mixing feels weird, like when you have the same project both. If it's not really a huge project, it will feel weird, I guess. So that I wouldn't do, I guess. But yeah, otherwise new projects, I would just go that one.
I have a question for you. your build system? Why are you using Maven and not Gradle?
That's just me. That's just me. I'm just so used to that XML files. So my folks have to deal with that I'm loving those stuff.
You're really using Maven and not Gradle? Like,
to be honest, it's probably like bad experience that I had at the beginning when Gradle, like, you know, when the phase was with Android coming out and Gradle was really sometimes not working as it should. So I never was never brave enough to switch.
Would it be the easiest switch? Like from Java to Kotlin?
You mean from Maven to Gradle? I don't think so. Fighting with the build system is not fun.
I have also a question.
Sure.
Have you ever used Scala? It looks quite similar to Kotlin.
I haven't used it.
Okay, yeah.
I guess they're quite. I mean, it's on JVM. They have like similar. I think they're also more functional than the Java world is, right?
It's more functional than Java. I also never worked with Scala, but I just saw your code and I thought, well, it looks kind of like Scala. Scala also has companion objects for Scala, for static functions and stuff like that. So I thought maybe you have some reasons why you should rather use Kotlin instead of Scala, because I don't know.
At least I hadn't one. To be honest, I hadn't looked at Scala. I just, like, as I said before, I was used now before the 2 years, I was used to, or more or less forced to program a lot of Python actually, because we just had it. And I came a lot of the Java world. And some concepts, when you get them, especially with the functional stuff, when you can mix those things, is really powerful. And then I just had a look like, okay, you know, Java sometimes annoys me. I have to write all those things where I could just like write 5 lines. And then I had read somewhere and I was like, hey, yeah, Spring Boot with Kotlin looks really fun. And then I saw that they even integrated it in the, like, you know, in the starter.io thing, when you like make a new project in Spring Boot, it's everything is already there, so they really deeply support it. Also, when you read through the documentation on the Spring Boot site, you see a lot of examples there. I even heard a podcast from, how's the guy called? Josh Long, I think he's called, where he's talking about how that they make all examples that they have on the Spring Boot application site always Java and Kotlin. So the Spring folks really want to integrate it. And Spring Native comes also. So if you like come with those resource things and worries, I guess another half in a year, then we'll be just like turn it on and it works. Like usually the Spring stuff is working.
Have you noticed any difference in performances between Kotlin and Java?
As I never have rewritten the same application, hard to say. But at least, but it's more like a gut feeling. It performs more or less the same in Java applications. So I haven't seen something. We have, like, as we've talked in the past, we have like a lot of like real-time applications where it's really important that we get the data through and pass them and stuff. So there performance-wise, we don't have any issues with Kotlin or with Java.
Okay, thanks for the wonderful talk. I'm happy to have you. And I would also like to ask Florian to come up here again real quickly. Because as it is, I mean, it's the second in-person installment, but tradition by now, we have a little gift for our speakers. So
thank you.
Thank you. Please have that. It's a beach towel with our Lakeside Tech Events logo on it. And you should use it, obviously, and tell people about the Lakeside Talks, because it would be awesome to continue this. It would be great to have different speakers from different companies, from different backgrounds, and people engaging with them in such a setting. Also to have such a thing in Klagenfurt again. So please spread the word about it. It would be really great if we could continue this. So that would be my thing for all of you. So, but with that, thank you again, and I'm gonna say bye to the YouTube audience. And for the rest of you, the pizza will be here soon, hopefully. So we planned a little bit later originally. So if you stick around, there will be pizza. There is already beer. There is other drinks. So feel free to socialize, network, and have some drinks and then later pizza. Okay, thanks.
Thank you.